So good evening, you all. So because of this mic issue, we just needed to start the session again. So basically, I have gone through this most of this introduction. So actually, this session series is about know what you're playing with. So it will contain multiple sessions about the technologies and softwares, some design patterns and principles we are using inside our office. So this first session is about the DynamoDB, and you will have many more sessions later with some other senior software engineers also. So today we are going to discuss about basically the DynamoDB. So I think you all already heard about this DynamoDB, right? Because here we have some newcomers, but almost other people have worked with DynamoDB in various projects. So let's start in a basic question. So what is a DB? I'm asking again. So now I think you have a better answer for that. I just need a simple definition to carry on. Anything?
It's where we can store data in a structured way.
Yeah, that's exactly correct. So simply, the database is a way how we store data and organize data and how we retrieve it effectively. So in that case, when you go through these terms like DB and DBMS, that can be bit changed, because DBMS is basically the database plus these management tools and softwares. So in that case, this definition is really good. I mean, it's how we store data and organize in a structured way, and also getting those data, how we retrieve those data. So the thing is, like in most traditional databases, like normal SQL databases, when your system getting scale up, there can be several issues. What kind of issues it can have? Any idea? There can be some performance bottlenecks, right? And also there can be availability issues. And also you need to think about how you handle your servers, and how you do your backups, and how you do these failing mechanisms. These kind of things you need to think about. But this DynamoDB is specially designed for these kind of scale-up scenarios. So here we are talking about like millions of requests per second and terabyte, petabyte of data. So it can have a good performance, have a better performance, even it having scaling up. And also the main thing, the best thing is, we don't need to think about the handling the servers, how to manage these servers, because this is serverless database. So this handling servers and kind of stuff, it will automatically handled by the AWS. We just need to think about how we design the database and how we going to store those data. We just need to think about how we use those data. We don't need to think about the infrastructures. But that doesn't mean, in previous also I mean like it's a better DB for when you're scaling up. But it doesn't mean it always like if you even if you just use a DynamoDB, we cannot guarantee it will resolve your all problems, because it's also having some limitations, right? Most of the engineers think like this is a serverless one and this is a cloud one. So because of that kind of scenario, we don't need to do anything. We just need to store data as we want, and we can retrieve data as we want. But still, this DynamoDB also have some limitations. So if we know those limitations, we can build around it, these limitations, right? So today I am going to explain about this DynamoDB stuffs and give you the high level idea about this DynamoDB. And the main thing today, I just need to do like here I have various kind of topics. I just need to fill gap between these topics, because I know you already know some kind of knowledge, you already have some kind of knowledge about DynamoDB. So today I just need to do filling these gaps between your knowledge and also connect these dots. So these are the topics I am going to cover today. As I previously said, this is just 5 topics, but session will contain more topics. This contains just 5 topics because of I'm lazy on creating these presentations. So let's go through these topics. I will explain better. I will include all the topics which I have. I just created this presentation to organize my data and the flow. So you can focus on me rather than the presentation. So basically, previously also we discussed about what is DynamoDB. So it is a fully managed NoSQL database, NoSQL, and also it that doesn't mean no server. That I just got it from ChatGPT, so I think that's why they have no server something. So always in this serverless concept also we have servers, but the thing is we do not manage it. We don't need to handle it. It will automatically handled by the AWS. That's the thing. So and also it's scaling better when you have sudden spikes or sudden traffics, and it do not have no downtime and handle massive and unpredictable scales. But in that case also there can be some limitations. We must know about it. We can discuss it later, at the end of this session. What are the limitations this DynamoDB has? So and also consistent low latency performance. That means even you have 100 records or even you have million record, in each time you will get a consistent performance from this DynamoDB. And also because of this performance and scalability kind of stuffs, and also this is really easy to manage because we don't need to think about server, it's managed by the AWS. So in that case, we have in most tech giant using it as their DBs. So this mainly developed for the Amazon. Firstly, it's developed for Amazon, and then it's using other tech giants also like Netflix and Disney Plus. So they mainly store their user activities kind of stuff. So when you go through a streaming service, we also doing some kind of stuff in our office also. So when you go through these Netflix kind of scenarios, they have a lot of user data, right? User activities, watch hours and what he watched and what he liked and kind of lot of scenarios. So in a very small time period, they have millions of user scenarios because it's using millions of people. These streaming platforms. So in those cases, it's using DynamoDB, but that's not saying it's only using DynamoDB, because these massive companies have several databases, several type of databases. Because even we do the session about DynamoDB, we cannot say DynamoDB is the best database in the world, right? They have other databases also. The selecting of the database based on the scenario. So that's why these massive tech giants like Netflix or Disney Plus kind of people also use separate databases according to their scenarios. So here they use DynamoDB as one scenario. That's the thing. So let's move to DynamoDB characteristics. So basically now we have basic idea of what is DynamoDB is, right? So but here also we are going to better describe what is DynamoDB is. So mainly it's a serverless and NoSQL. We already know what is serverless means, and NoSQL means we also know what is a NoSQL means. When you go through the SQL databases, those are pretty structured, right? Using tables, columns, rows, and mainly focus on these relationships, and also it contain fixed schemas kind of stuff. But when it comes to this NoSQL side, it's more flexible than that. It contains flexible schemas, and its data structures are flexible most of the time. And when have you ever heard about this scaling, like vertical and horizontal scaling? Have any idea? What do this SQL databases? How it is scaling up? What mechanism it uses? This vertical or horizontal? Vertical scaling. Any idea? Yeah, SQL uses vertical scaling, right? That means it's what that means actually.
You have the same infrastructure, you
Mhm.
leverage it on
Oh, okay.
instead of expanding.
So in that case, NoSQL, we can have several. We can separate it into other components also. Like we can have several machines with that, with several servers, rather than increasing performance of a single server. So that's very easy to scale up, and also it's cost effective. That's the thing behind this DynamoDB also, and also it has this single digital millisecond performance at any scale. That's also we have discussed, right? This because it doesn't matter. It contains hundreds of records or thousands of records or millions of records. It always give you consistent result most of the time. And also, it provides ACID transactions. So, do you have any idea what transaction is? What is a transaction is? Any idea?
Data writing something data writing or
Yeah, when data writing, if you think about a scenario about data writing, it's a database operation, right? The collection of database operations we calling as a transaction. So in that case, we can have several database operations. So as an example, think you have a think of a bank transfer. So here we have someone called A and someone called B. So B has an account record in the database, and B also have an account record in database. So A contain 100 and B contain 50 amount of dollars in their accounts. So think A need to transfer $50 amount to the B. He is going to transfer 50 amount of dollars to B. So in database, what will be happen? What record need to be updated? This is a simple scenario. This is not how actual database system handles in financial world. It's a very complex thing. But for this scenario, just think they have two records. Here one have for the A and one have for the B. So what will happen? When A need to transfer $50 to B, it will deduct from the A and add to the B, right? For these records, for these amounts. So here it will deduct 50 from A and add 50 to B. But in some scenario, because of a special reason, some failure or something, what happened if this second transaction didn't happen? Not second transaction, this second update didn't happen. What will happen? It will only be deduction from the A, and there will be no record in B. So somehow this money has disappeared from A, didn't add it to the B. So this cannot happen, right? This is issue. And what happened if it is just added to the B and didn't deduct from the A? In that case also same thing, right? It cannot be happen because somehow B got $50, but we don't know how it got. So in these cases, can you see these two operations, updating the record A, updating the record B, both should be happen. or both should be failed. That's guaranteed from the ACID principles. So basically ACID means can you anyone just tell me the names? Atomicity. This consistency. This isolation. This is durability. So what this means? Atomicity means this can be what we discussed. These two transactions can be either success or either fail. There cannot be other scenarios. And consistency means it should be consistent, the state of the database, even before this transaction and after this transaction also. As example, think this A just only have $10 here. So you are going to deduct he is going to transfer $50 from his account. But then once we deduct this 50 from this 10, there will be minus, right? That not the valid state. And also it should be isolated. That means when you run transactions, several transactions simultaneously, those cannot be interfered with others. And also the durability. Durability means like when you commit the transaction, after you commit the transaction, those data must be available. Even your system crashed or whatever happened, it should be available. When you try to fetch it future, it should be available. That state should be in that state. And the thing is, most of these NoSQL databases it's not follow the ACID principle, it follow the base principle. Oh no, base principles. Do you have any idea what is the base principle is? Okay. This means basically variable. Soft state and eventual consistency. That means the basically available means when we think about these kind of DynamoDB scenarios, always the system should be available, always. And also the soft state, the basic idea I'm just giving you. The soft state means the state can be changed over the time. Even user didn't do anything, this state can be changed. And also this eventual consistency means it will not give consistency in the same time, but the data will be, the states data will be consistent after some time. Not at the exact time, but after some time it will be consistent. But the thing is here, in DynamoDB, it's support for ACID transactions also. It provides you APIs for the transactions, special APIs for transaction, write transaction and read transaction. Those also have some small limitations like how much database operation can be included in a one transaction kind of scenarios. So you can go through it, but it provides this kind of ACID transactions. That's the thing. And also, I think you got an idea, right? So the next thing, change data capture from event-driven architecture. So here, this support for event-driven architecture. That means this contains a specific mechanism called DynamoDB stream. So when data change appear inside the DynamoDB table, it will start a stream. So if someone subscribes to this stream, then they can get that change from the DB. And in GSI also, that's also working using these streams. We can discuss later how this GSI works, but just for idea. The next thing is this support eventual consistency and also strong consistency when you ask. So have you heard about cap theorem? There are a lot of theories, right? We have a theorem called cap theorem. So the main idea is this DynamoDB is a distributed database. Not just a database, it's a distributed one. Distributed one means, have you any idea?
Backend infrastructure is distributed among the nodes or something.
Yeah. That's the exact thing. Actually, that means it is distributed over various physical locations or various nodes or various servers. It don't have a single machine or single server. So normally in DynamoDB, we have like when we creating a normal default table, then it will automatically create some replicas inside that region. So as an example, if you use the US1, then it will create several replicas inside that region, and it will distribute it among these different availability zones, these replicas. So normally it's 4, as I remember. That number can be changed. So when you're writing a data, this one of these replicas will act as a leader. So when you write, you just only contacting with one replica. It will communicate to others, and it will update eventually. And so I was talking about cap theorem, right? So do you have any idea what that means? What is C for? Yeah, consistency. The same thing we previously also discussed, but not the exactly same thing. And A, availability. P?
I'm not sure the price, I guess.
No, partition tolerance.
Price.
Partition tolerance. So thing is, in cap theorem, what they describe is, we only can have 2 things from here. We cannot guarantee all the 3 things in a distributed system. That means a distributed system can be consistency and availability at the same time, but it cannot be provide these all 3, like consistency, availability and partition tolerance. So consistency means when you are updating something in the DB, when you inserting or do an operation in the DB, at the same time you can get the latest data. That means the consistency. So I think you are updating this record in here in the A. In the same time when you querying it, you will get the same updated data. That's the consistency. Then availability means the system always should be available. It should always provide a response when we doing a request. And also this partition tolerance means these distributed databases are connected, these nodes connected to a network, right? So in that case, even a network failure happen, this system should be well. Right? Then just let's take a small example here. Think they have for DB they have 2 replicas. One is A, one is B, and they have 2 users. Right? So think A going to update something in database this replica, but they have a network failure. In that case, this update will never sync with B, right? If network failure happens. So B is trying to get the same data from the this replica B, what will happen?
It gets no data, gets stale data.
Sorry?
B gets no data at all or gets stale data.
Yes, that's the thing. There can be two scenarios. The system can do two things. What are those two things? It can provide the old data, right? Otherwise, it can provide, it can show an error or something. This is network failure happens. So system is not available. So think the scenario A, scenario 1, provide old data. And scenario 2, show error. So in this case, what will be break from these three? When you provide the old data, what will be break? Consistency. Exactly. This will break the consistency. What will break here? This breakable. So that's the thing. So when it provides this partition tolerance, I mean, if system works even in a network failure, it can only provide either this consistency or availability. It cannot provide both two with that partition tolerance. So it can only be PA or PC, not all three. So mainly this DynamoDB and most of the DBs are not most of the DBs. DynamoDB is PA, partition tolerance and availability. And they have another scenario. Most of these distributed systems, distributed databases are connected through networks, right? So network failures can happen. So in that case, most common thing is PA or PC. It supports PA or PC because of the network failure happen. So this DynamoDB is also PA by default, but it can provide the strong consistency if we want. So now you may have a question: what is the eventual and strong consistency, right? So we discussed about consistency. That was a high level idea. This contains two types. One is strong, that we consider as the actual consistency. The second one is eventual. So strong means when you update the data, in the exact time you will get the same data. But eventual means you will get the same data, but after some time. Those data will be consistent, but it can take little bit of time. So in this DynamoDB, it can take like 1-2 milliseconds, but it's not guaranteed. But if you want this strong consistency, you can mention it and you can get this. And it provides this strong consistency also. But it's not provide strong consistency in all the scenarios. They have some limitations for that also. We can discuss later about that. The next thing is predictable performance. We discussed earlier too. That means like in all the cases, like mainly these AWS services are known for this predictable performance because most of the cases it don't have much variance from the first scenario to next scenario. That means like even when it is scaling up and even it's a different types, that doesn't matter. Always it most of the time giving the predictable performance. So it is easier us to handle this, right? Because it's not giving first time when you querying data from the DB first time it will give 2 seconds and after it will not give you like 2 minutes. So it do not have that much variance. It will always will be around the 2 milliseconds kind of. So that's the DynamoDB characteristics. So I think you have a better idea about how this DynamoDB works now. Some idea. You can go through it and go through for more knowledge. So we can move into the next part. So the data model. This is the This is the main thing when we discuss about DynamoDB table design, the data model. So basically here it is document and key value models. I mean it supports for both. So key value means we have a key and a value. Simple. And in the document model, we can have multiple key value pairs. It's like a JSON object in the JavaScript. So let me clean this. Okay, nice. So what I was talking about? Document data model, right? Okay. So mainly first think about this key value model. So in there you have just key and values. So think a user. So user ID, you will have the user ID like 129, and also values like name, maybe my name Shashika, and maybe age. Oh no, we do not store age, right? Because it's a derived attribute. We do not store that kind of attribute in a database, right? So this need to be birth date. Birth date. And also maybe telephone number. Sorry, so this should be value, right? Mistake. Kind of this. So in that case, a DB cannot understand these values. It can only understand the key. You cannot query it by the name. You cannot ask DB to give some value which is equal to Shashika, because it do not understand it. You can only query or do operation using just this ID, because it's the only thing it can identify. But in document model, it have multiple these kind of key value pairs, like it will have the user ID 129 and your name Shashika, date, birth date, kind of this. So in that case, it identifies these attribute names also. It has knowledge about attribute names. So you can search data using these attribute names also. That's the main thing. So in here we use this document model and also key value model. It support. And inside this document also you can have some key value pairs also, like same thing. And also the thing is here it's flexible schema, not as like in SQL. Here we have a flexible schema. In SQL it's have a strict schema. We need to design the schema first. But and before that, let's go through what is a table and this concept, right? So in DynamoDB also we have tables. So we are storing data under these tables. That's how it works. So this data under these tables we are calling as items. These are those DB records. Those data is stored as these kind of document models, document objects. So those are calling as items. And also it contains key value pairs. That means like this attribute name and the value. This is how it is stored. And also this contains a primary key. What we use for use this primary key? Why we use primary key? Sorry?
Uniquely identified.
Unique, yeah, that's the thing. To uniquely identify data, we using a primary key. The simple thing, right? So here we have key called partition key and key called short key. So combination of this can be primary key, but this short key can be optional. So we can discuss more about partition key and short key later. So first let's discuss about this flexible schema. So that means you just, in here it's only strictly asked for this primary key, that's only. Other attribute can be null or can be not present in there, that's fine. Like in here, for this user, we have a telephone number. But for the second user, there will be no telephone number for that user, right? So in that scenario, that's not an issue in here, because it's this kind of JSON objects, right? So it's not an issue if you missing any of these attribute or value. That's not issue. But in SQL, then you will have this kind of equation. Like in SQL also we can have nullable, right? Nullable attributes also. So what is the difference between there are nullable attributes and here not presenting the missing values? What is the difference? So in there, the value will be nullable, right? There will be the attribute. The value will be nullable. The column will be always available in there. But they have the value, that value got nullable, null value. But here, it doesn't exist. That's the thing. So then we discussed about this primary key, and we also discussed this primary key created using this partition and short key. So in that case, this partition key is we must need this partition key, but this short key is optional. So partition key, so in here, in DynamoDB, they have a special concept called partition. So that means if you use same partition key for store several items, those all items will be go to same physical location. It will store in the same physical location. So because it's stored in the same physical location, we can get it easily because database already know where this all data is stored in, right? And also this short key, if you use the short key guarantee how these data organize inside that physical location. It's working as a some B-tree index, like you can use it as a filter. As example, think you have this date time as the short key. You can get, think about a scenario like you are going to store a product records, right? Product data. In that case, you using short key, this date time as the short key. So using that, you can get the orders, those products or orders which is received like 2 p.m. to 3 p.m. or maybe orders from past month or orders from yesterday. Those kind of filtering mechanisms you can do with this short key. So if you use only partition key, it should be unique. But when you use this partition key and short key, the combination should be unique, not the partition key. The combination should be unique. That's the thing. Okay. The next thing is the access patterns. So maybe in SQLs we mainly focus about schema and relationship kind of things. But when we designing a table database in this DynamoDB, the main thing is the access pattern, not the relationship or data. We first focus on access patterns, then according to it we organize the data. That's how we do in here. So in that case, what we are going to do is like design queries before designing table, and in that case we mainly focus on reads, not about this storage. There can be a lot of duplicate data. That's fine, because in DynamoDB, if you add a secondary index or something, we can discuss the secondary index later. it's always do like duplicating data. That's the thing. But in old days, the storage there was something like what is the more important? In old days, it's storage because we had some limited storage capacities. But nowadays, it's a time, right? How much? How efficiently can we access those data? That's the main thing nowadays. In some cases also, currently also we need to focus on storage also. But most of the cases like these Disney's user activity scenarios kind of things, it's mainly the scalability and also how to access the data. So here we mainly optimize it for reads, not for the storage. And also each access pattern is specify a query. So let's go through an example. So think about a scenario about storing product review data. So in that case, you are going to store the product review and ratings of this review have, and also maybe some other data. Okay, so you need to get this product data. First, I have mentioned this is basically we need to think about how we access this data, right? Access pattern. So think you need to list those data using the product ID. So in that case, what will be the access pattern? Get this product, get product reviews, by think product ID. In this case, you just need to get those product review data using the product ID. So in that case, and also you need to do filtering based on its date time. Think of that kind of scenario. In that scenario, what will be the PK and what will be the SK? This will be product ID. This will be date time or timestamp. Have you got your idea? Like, so since we using product ID as a partition key, this will be stored in the same physical location. So it know when user asks for this product reviews by product ID, it just need to go and look for the same location, right? Same physical location. It do not need to go through all the data or something like that. And also we can filter it by the timestamp. Think then you will have another scenario. You need to get this product data from the ratings. You need to sort it using these ratings. Like you need to get reviews for a specific product and organize it by ratings. What we can do? We can have another short key. This is simple. You can have another short key. So this short key will contain the same the partition key, this product ID, and the short key will be the charge rating. Now you can do two things. What you can sort this and filter this using date time, the timestamp, and also using ratings. So these kind of extra additional short key indexes calling as LSIs. These are LSIs. And also think another scenario, you need to query it by use ID. Users predicted. So in that case, what you can do? Previously we can do query by product ID, but now we also need to query by product ID also, and also we have another scenario, we need to get it by use ID also for a specific user. So in that case, this DynamoDB support something called GSI, Global Secondary Indexes. So in this GSI, also we have partition key and short key. We can add partition key and short key. So here we just need to add, I will add here GSI PK, partition key, and GSI short key. So partition key will be use ID. Short key will be timestamp. This can be different. I mean, if you want to filter it by timestamp, then you can use the timestamp. Otherwise, you can think a scenario, you need to filter it using the ratings. In that case, you can use ratings here. That's totally fine. Always the access pattern first. Based on the access pattern, we design the keys. That's how it works. So when you talk about GSIs, so in GSI, when we create in GSI, they have three types. We can have only key value, only these keys. Or otherwise, we can have all the attributes in the base table. We can duplicate it. And otherwise, we can define what attributes we need to duplicate. So they also have a limitation. When you specifying attribute, it will be only hundreds. You cannot specify more than 100. But you can duplicate complete data. So in QR Flash, I think we are duplicating complete data for the GSS. And also the next thing, how this GSI works. So normally, these LSIs also in same physical location, but GSI will be in different. So this update happens using DynamoDB strings. Once database update, once this base table updates, it will start a stream, and once this stream happens, this GSI will be updated. So in that case, this cannot guarantee strong consistency, because it can have some time to update, right? But it will consistent after some time, but it will not guarantee. At the same time, you can get the updated data. That means this only can support eventual consistency. But for LSIs, you can support strong consistency also, because it's in the same physical location. That's the thing. Okay. So I think we have gone through these access patterns, and here we have some data access operations also. So here we have some read operations, write operations, fetch operations, and they have some other operations also. So like creating the table and kind of those. So these are like, for read operations we have get item, query, and scan. So get item, we need to specify this exact partition key and the short key, and it will give you the exact just one item. That's the item which matching these two keys. And also that means a primary key actually. If you don't have a short key, then you don't need to mention it. If you only have, if you have two keys, then you need to mention both keys. And when you're querying data, query means you can use, they have two options, query and scan. So for querying, you need to know what the partition key is. So if you know the partition key, then DB know where the location it need to be searched, right? And also when you come to scan, it's going through all the data and search for attributes, search for the item. So when you're designing a DB in the DynamoDB, you need to reduce these scans. You need to have queries always reduce scans. That's the main principle when you're designing a database or table in the DynamoDB. And also here we have some write operations for put item, update item and delete item. And also they have some batch operations also. So you can get multiple data from a single request. You can get you can do multiple get item commands in a one request. It's a batch get item and also batch write item. That means you can write several data in a one write request. Then the next thing is a extra point. It's the single table design that we are using in our company also. For we use it for several projects. This single table design. It's a very specific thing. So think about this example. Here you can see a user trying to get information about him and his orders. So normally don't think about this single table. So normally how we store these separate entities. Think about this customer entity and order entity. How we store it normally in DB as separate tables, right? Normally we store it as separate tables. So in that case, in SQL we have joins. That's fine. But here we don't have joins. So in that case we need to do two requests. One for the customer table to get the customer data, and then using that customer ID we need to get data from the order table also. But in DynamoDB the specialty is we can store multiple entities inside the same table. That's the thing. So it provides this it provides the same kind of relationship thing which have in the SQL also available in the DynamoDB. Not the same thing, but same kind of behavior. So in that case, don't think about this. Let's extend this example furthermore. Just think in this DB you have products also. So you need to get, let's have a access pattern, like you need to get product details for a specific view. For the front end you need to get product details and also its reviews. So this case, if we store these product and product reviews in separate tables, we need to do two queries, right? First we need to get product details, then we need to query these reviews from the second table. But if we can store this product also inside the same table. So if we store this product ID as the partition key in the same table and its other details here, then when you're querying it from this product ID, what will happen? It will give you this product review and also the product data. You can get both in one single request. So in that case, it can be in a database we can store all the entities in a single table. That's fine. In our project like that, QR Flash also we doing the same thing. We store all the data inside a one table. But also we can have like separate tables, but several entities in a single table. That also fine. It's based on your scenario when you're dealing with the database. And the thing is, when you're doing this kind of stuff, this kind of single table architecture, you need to avoid these scans. But in here it's very important because here we have lot of data. not just only data which belong to products, right? Which contain product and also product reviews also. So when you do a scan, it goes through all the data. So you need to always avoid these scans in here. So next thing is the pricing. So this designing single table is a very big topic, and they have some lot more to talk about it. I mean, it will be another session how we design a single table architecture. So I think you have a basic idea how we need to design a single table, right? So by yourself also you can go through these things like this single table architecture and have some knowledge. I just need to give you some overview about all the concepts. So next thing is pricing. In there we have two capacity modes, on demand and the provision. And in there they have a measurement how we measure these reads and writes. So as an example, when you do a read, they have a measurement called read capacity, and when you do a write, they have a measurement called write capacity. So basically, read capacity is like this is number of read. Just forget this. It means like when you do a query or when you do a read, if it is strong consistent, you can have one. It will be one read capacity unit, but it should be under 4 kilobytes when you do a query. And if it is under 4 kilobytes, up to 4 kilobytes, and it contains this eventual consistency, then you can have two requests. Then it will consider as a one read capacity unit. But if you use strong consistency, one request is considering as a read capacity unit. This is for reading actually. This consistency is specifying when we read it, not we write it, right? Because reading is a thing here, this consistency. So when we write also, it's item up to 1 kilobyte. For single request, it's item up to 1 kilobyte considering as a one write capacity unit. So based on that, this on-demand pricing is happening. Based on this read and writes capacity units, we are going to do read request and the write request. So here it's when you use the on demand, you are not defining any limitations. So it will automatically scale up. When you have a sudden traffic or something, it will automatically scale up. And you paying for the request and the storage. These storages are not very expensive. These read and writes are the main thing here. But in DynamoDB, it provides you some amount of free tier, and also after that it will cost you for you this read and writes. And also, as he mentioned, it handles sudden traffic spikes. But even in on-demand mode, there can be throttling situations. We can discuss it later. So the next thing is provision mode. We can define this read and write capacity, how much this table has, and also we are paying for this provision capacity what we have configured, not for the read and writes. It's for the provision capacity, and also it's supporting scaling also. But in there we can have minimum and maximum scales. Between that, it can automatically scale up or scale down based on the traffic. And also, this is best for predictable workloads. I mean, if you know your workload, if you know about your traffic, then this is the best thing. But if you don't know about your traffic or you doing some testing kind of scenarios, the on-demand mode is fine. The next main thing is the limitation. So this is a very important thing, because as I previously mentioned, even you use DynamoDB or any kind of database, other NoSQL database or serverless database, it can have limitations, some constraints. It's not provide ultimately everything. Right? So here we have some API limits also. Like as example, when you do a batch get item, the maximum it provides you 100 items, and it should be under 16 megabytes. And also when you batch write, it's 25 items. And also when you query some data, it will be just 1 MB. If you have more than that, it will provide you the last evaluated key, something called last evaluated key. That means like using that last evaluated key, you can paginate through it for the next batch. You can query it again for the next batch. That's how it happens. And also the next thing is hot partitions. So this hot partitioning situation, we had this hot partitioning situation in our several projects. One project we have worked with some batch processing things. So in that case also we had this hot partitioning thing. So here hot partitioning means you making request for single partition, for one single partition again and again. It has a limit. For single partition, it only can handle 1000 write capacity units and 3000 read capacity units. If you consuming more than that, it can be throttled. That called the hot partition. Think this like a, maybe it's like a highway route. Maybe it's like a highway. It contains 6 lanes, but all the vehicles are going in one single lane. So in that case, the capacity getting that capacity is not enough for these vehicles, right? So in that case, there can be this bottleneck. So in here also the same situation, the table can afford more write and read capacity units, but you doing request for one single partition always. So it makes this partition, this hot partitioning thing, this throttling thing. So how do we solve this issue? Have any idea? If they have hot partition, if they have a solution, how do we solve this? Sorry? Yeah, replica, and the main thing is we can distribute the key. I mean, in here we have the we have one partition key. We can distribute it to other partitions also, right? I mean, when it comes to write, it always calling this lead, right? It's not going to other replicas. It's always calling to lead. So when you're writing something, if it have more than 1000 RCPU, it always getting throttled. But if you distribute this key across partitions, then you can distribute this heavy load across partitions. So for that also they have some several mechanisms. So for that, like just a simple scenario, we can add some random number to the end. Think we are adding like 1 to 5 numbers, 0 to 5 numbers, maybe 5 numbers. Just think we are adding 5 numbers. So in that case, first we had only 1000 write capacity units, but after adding 5 numbers, how much capacity units we will have? I mean single digits, like 1 to 5 numbers, 1 to 5. We are adding 1 to 5 at the end of this partition key. It will be like this product ID hash 1, then product ID hash 2. Likewise, it will have until 5. So how many write capacity units it will have? How many partition keys then we will have? If we added 1 to 5 numbers, how many partition keys we will have? 5. Then one partition can have 1000. So 5 partitions can handle 5,000. That's the thing. So in one of our scenarios, the client didn't want to do this distributed thing, distribute across partition. He wanted to use always this same same partition. So in that case, what we did was we added a backup algorithm. So in there, we trying to write all the records that we have. Then when it's failure, then we get those failed records and we waiting for another 5 seconds and we retrying again. And if again failed, we will get those data, the failed data, and we will wait for 10 seconds and again we are going to try again. So that was the scenario, that's how we handled that scenario. And also, so we mainly focus on this hot partitioning because even that table consists of this, table can handle this traffic, but that partition cannot be handled. So that's a one limitation you always need to think about. And they have some scaling limits. So even in on-demand mode, if you have a huge sudden spike in traffic, that can be throttled. It will take like 10 to 30 minutes to scale up for that kind of large scale. It can automatically scale the size of twice as before, but if you have a very huge one, then it will take some time. So in that meantime, those requests can be throttled. So you need to know about these throttling scenarios also when you design it. And another thing we have discussed this earlier, the GSIs are eventual consistent. So it's not guaranteed this is strong consistency. So its data can be a bit old sometimes. It's not taking much time, like 10 to 20 minutes. It's only taking 1-2 milliseconds. But in the same time, if you trying to query data, in that time that can have the old data, not the updated ones. And they have item size limitation. So in DynamoDB, we can have 400 KB for single item. One single item, we can only have 400 KB. And if data bigger than that, what can we do? Think you have your one item size is more than 400 KB. What can we do? The simple thing, we can split up. We can split up and use a short key for arrange it. And also, they have other mechanisms like we can compress it or kind of other scenarios also we can do with those data. And also we can move that large part to S3 storage, and we can have index inside the DynamoDB. That's based on the scenario. So, but it cannot contain more than 400 KB. And also batch limitations. That means when you doing a batch write, this scenario also we handled in here, I think for the QR batch. This scenario, batch processing. Yeah, in both scenarios we have handled this. When you trying to handle more writes, like in a single code, like when you using the batch write API, it not guarantee all the data will be added successfully. Some data can be failed. That's the thing. Some of those data can be failed. So, if failed those data, we need to handle it by ourselves. That's the thing. So, it's not guaranteed from the DB side. We need to have some mechanism for handle this failed data. If we retry it or something like that. So, these are some sort of examples here, like the limitations here. So what I wanted here is, I just wanted to mention, like this DynamoDB not provide you all the things. Like it's not an ultimate thing. it also has some trade-offs, some limitations, some constraints. As engineers, we must know about this constraint and these limitations, and then we can build it around our solution. We can build our solution around these limitations. That's the thing. So actually, this is the end of the presentation, the session. So I think we have discussed about multiple topics here. I think you have some idea about this DynamoDB and how these data models work and the single table a little bit, and also these limitations. So I just wanted to connect these topics together and give you a small flow. So now I think you can go through these topics also furthermore and have more knowledge. So thank you very much for listening actively with me. Actually, I'm really happy because you actually listening and actually participating for the session. And this is, I was also very curious about this session because this is the first time I'm conducting this kind of session in English medium. I have done it in Sinhala for you guys also, but this is the first time in English. So yeah, if you have any question, you can ask from me, and you have any thoughts or kind of things, you can share. That's it. Thank you.
I think anyone has not got any questions, and therefore, as the wrap up, I would like to share out my gratitude towards Mr. Sashil Gulaj, who is a senior software engineer from our company. And actually, talking about the session today, I was enjoying a lot, and I think the rest of the people as well. And as you have said in the beginning of this session, what you have already tried to do is creating a mind map or creating a bridge between all the concepts that we have collected so far this journey, and you was able to create some mind map or the sequence of knowledge, and I really appreciate it. And I would like to appreciate the skills and the teaching skill that you have shown throughout this session, and thank you so much for organizing this and conducting this. Thank you very much.
Thank you. Okay, then next session will be with another senior software engineer, not me. Okay, nice. Thank you. Bye.